Now, guys, just to move things on, we're going to look today at combined events. What page is this? Let me have a look here. In your books, this is page 332, okay? Page 332. So when dealing with more complicated questions involving probability, it can be advisable to use a two-way table or a tree diagram, just like we did in the last chapter, or was it the beginning of this chapter? I can't remember, but anyway, we did it just before Christmas. It's especially the case when dealing with probability of combined events. A combined event is where two or more experiments occur and the outcomes are combined together, okay? So, yeah, let's have a look a little. I'll just look at the worked examples in the book, okay? I'll give you some homework and we'll correct it then tomorrow. So you have two fair dice are thrown and the scores are added together, okay? Simple enough. Draw a two-way table, show all the possible outcomes. And B, find the probability that the sum, that's where when you add them up, of the scores on the two dice is, and you have a load of them there. Okay, let's have a look first of all, the two-way table. So that's how you do a two-way table for that. You have the first die here with, or the second die, whichever, it doesn't matter actually, 1 to 6. They're the outcomes on both dice. And then you add them. So for instance, if you roll a 4 and a 5, when you add them together, you get a 9, of course, okay? So that's what this is all about. And that was part one. You have to just do the two-way table. The biggest number you can get, of course, is when you roll a 6 and a 6. And when you add them together, the sum of them gives you 12. Okay, that's it. Now, how many possible outcomes are there? The total possible outcomes are 36. There were 36. If you count up all of those, there's 36 of them, okay? You don't have to count them up though. If you're clued in there, you know that it's 6 multiplied by 6, which is 36. Okay. Part B. Now, find the probability of a score of 7. Okay. Well, you can see in green there, they've highlighted how many 7s there are. There are 6 of them. Okay. So it's 6 over the total number 36. Okay. Or 1 over 6 when you reduce it. Okay. Part 2. A score less than 5. Less than 5. Well, if it's less than 5, you're talking 4, 3, and 2. So you can see them in the red there. And how many are there? 1, 2, 3, 4, 5. So there's, is it 6? Yeah, there's 6. 6 red boxes there. That's 6 over 36 or 1 over 6. Probability of your score greater of 5 or greater, of 5 or greater. So you're talking about all of these. Basically the opposite of what we just did up there. So if the probability of getting less than 5 is 1 over 6, then the probability of getting 5 or greater must be 5 over 6. I hope that makes sense. Okay. Or you can just count up the white boxes here, as I said. All right. And that'll give you, there'll be 30 of them, and that reduces to 5 over 6. Next one, probability of a score that is even or divisible by 3. So even or divisible by 3. So you could start by just getting all the even ones. Okay, all the even numbers first. Highlight all of them. Even. All of these are even that I'm circling. Okay, they're all even. Okay, what about divisible by 3? 3, obviously. 6, so we've already highlighted that one. 3 here. 6, 6, 9, 6 again, 9, 6, 9, 9, and 12, of course. Okay, so any box there that has a pink or a green, you add them all up. Or the way they've it done there, they've it done better than me with the orange boxes. All divisible by 3 or an even number. So count up all of them, and there seems to be 24 out of the 36, or 2 over 3. Okay, and the last bit for that question, the probability of that a score is even and divisible by 3. So that's a little bit different. So even and divisible by 3. All the 6s, even number, and also divisible by 3. Count them up there. Looks like 6 out of the 36. or 1 over 6. Okay. Next worked example. Here's a spinner. It's spun 3 times. Use a tree diagram to determine the probability of the spinner landing on. So let's do the tree diagram first. So you do a tree diagram. Don't forget, when you're doing a tree diagram, that you should have a starting point halfway down your page, because then it branches out like this and it can get quite big. So go halfway down your page and have a starting point. So you look, there's only 2 options here, green or red. On the first spin, so you have your headings here. This is for the first spin. This is for the second spin, okay? And for the third spin, all right? So we have our headings there. So you can get, no matter what, your choice is always the same, green or red. So maybe you get, let's follow one of these branches. Maybe you get green on the first one, okay? And then you get on the next one, so you get green on the first one, then you get, let's say, red on the second one, okay? And then you get green on the third one, all right? That's just one of the options, green, red, green, okay? Now we can see how many options there are altogether. You know, there's, you can count it this way if you want, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 options, there's 8 outcomes altogether, all right? Like I said, green, red, green was one. Another one would be green, 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 or green, 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 or green, green, red. That would be this one. Or we've done the next one, green, red, red, that one. Or red on the first one, green, green, and so on, okay? Or red, green, and then red on the last. Red, green, red, red, and green. Or red, red, red. Okay, so there are all your options. I'll just take away all this in case it's confusing. Okay, there are all the possible outcomes. So there are 8 different outcomes. What's the probability of getting 3 red sectors? 3 red sectors. So red, red, red. There's only 1 out of a total of 8. So 1 over 8. Okay. Another way to do that is the probability of getting a red here. So a red, red, red. So probability of getting red is a half, because it's only a green or red. So there's 2 choices. So the probability of getting red there is a half. The probability of getting red here on this spin is a half. And the probability of getting red here is a half. And a half multiplied by a half multiplied by a half is also 1/8. But I think I prefer the way they did it here, where they list out all the outcomes and then you can see clearly which one. Next one, part 2. What's the probability of a red sector followed by 2 greens? A red followed by 2. And if you've done it this way, where you've listed out the outcomes, you can clearly see a red followed by 2 greens only happens here once. So it's 1 over, so red, green, green, 1 over 8. And the last, I think isn't the last, no, it's the second last, probability of getting a red and 2 green sectors in any order. So basically getting a red and 2 greens in any order. We count how many times red, green, green appears in the outcomes, ignoring order. There are 3 outcomes of which, out of the 8, which this occur. So a red and 2 greens in any order. Let's have a look more closely. So a red and 2 greens, that's 1. A red and 2 greens, another one. A red and 2 greens, another one. And that's it. Yeah, so as they said, 3 out of the 8, okay? Now, what's the probability of getting at least 1 green? At least 1 green. Okay, let's maybe have a look again. So probability of getting at least 1 green. Well, there's at least 1 there. There's 3, in fact. There's at least 1 green here, at least 1 here, at least 1 here, at least 1 green here, here, here. That's the only one where there's no green. So the answer for this one is 7 out of 8. So there's a 7 out of 8 chance. Okay. There's an alternative method to doing that too. I mean, if you can see here that there's 1 There's one occasion where there's no green. So if that's the case, then the other 7 must have a green. What I want you to do, guys, is listen, do what you can. I'm giving you these questions. You know, if you don't have time to do them all, that's fine. Just do some and upload your work. As I always say, upload your work to the homework section on what you call it, OneNote. Okay, put it up there with a date. Kind of make it easy for me to follow, please, by putting the date and the question number. Some of you are great at that, by the way, so that's great. Others are just putting it up in no order, but at least you're putting it up. But just to make it easy to follow. So questions 1, 2, 3, 6, 9, 12, and 15. Okay, listen, if you're finding the first 1, 2, and 3, if you find them easy, just go on to the harder ones. But do some work anyway. Whatever you do, just do some. You can do more than that. You can just do less if you want, but make sure you do something, okay? So question 1, 2, 3, 6, 9, 12, 15, and I'll correct the hardest ones of those tomorrow then, okay? As always, email me or whatever if you have any issues, okay? Thanks, guys. Talk tomorrow.